Hello everybody. My name is Jim Pingle and welcome to our March 2017 Hangout. This month we're talking about high availability using CARP, XMLRPC, and pfSync. This is updated for pfSense 2.3 and 2.4. We have done a couple of Hangouts on HA previously. We had a basic one a few years back, and then we had a one with some more advanced topics last summer. This is updated for 2.3 and 2.4, and also I added some more information about IPv6 and a few little edge things here and there. So, first up for the month is project news. We have a pfSense 2.3.3 patch 1 out. There's a few beneficial improvements, bug fixes, things like that. A couple of security updates. OpenSSL and curl had updates. We've got a blog post there if you want to read about it if you're not already running it. Our pfSense blog did move under the Netgate domain. We tried to consolidate everything into one blog rather than maintaining two, and we also wanted to get rid of WordPress. There's been some pretty nasty security issues with WordPress lately. So now it's a static site that we generate with Jekyll, and it's really slick, a lot less overhead, and a lot better security profile doing it that way than there was with WordPress. So check that out if you haven't yet. Also, if you have most of our SG device owners, not the 1000, but like the 2220, 2440, 4860, 8860, and the XG 2758, you should have received an email that had some notes about an upgrade for core boot, the BIOS for those, to work on one of the Intel errata for the SERQ issue. If you didn't get the email, it's okay. But you have one of these systems, there's a package we put on there to install the BIOS update automatically. Just go to System Package Manager and search for core boot. You'll find it there. If you have any questions, if you're not sure if your system is affected and you didn't get an email, whatever, just drop us a note in support and we can look that up and see if it's relevant to your hardware. Again, that doesn't cover the SG-1000 because that's a different architecture, but it doesn't use core boot; it uses U-boot. But the others, you want to check for that BIOS update or core boot update rather. We are going to have some more training in Europe a little bit later this year. If you want to look into that, you can go to netgate.com/training. We're going to also have a preview of our remote device management platform in that. So we're going to our new architecture we're going to have where you have one box or service you can log into that will manage a bunch of different remote devices out there. So that's going to be pretty slick. But our training is going to be in Paris, France, London, UK, Frankfurt in Germany, and St. Petersburg, Russia. You can see the dates there. If you happen to be around any of those cities, you can check it out. Also, another update, we do have some documentation out there now for our Let's Encrypt Acme package. So if you were looking for some information on that, we do get quite a few people that were interested in that. There's some better documentation up on the wiki now where you can get some information about creating certificates for your firewalls. Okay, well, about this Hangout, what we're going to do this month, we'll talk about components of a high availability cluster, the technologies that we use to put one together, sort of the theory behind it all, the prerequisites or things you need to move forward with an HA cluster. And then I'll go over the configuration of a cluster from a default configuration onto 2 units. I won't demo the whole configuration. I've got one set up. I'll show you where you go and things like that, and how it's done. But I don't have one to start from scratch right at the moment. How you would go about testing it, and how you would troubleshoot it if there's a problem, and upgrading. And along the way, if we have any questions, we can always handle those. Somebody said they're not getting any sound. Let me test it here. Is it coming through? Yeah. On my test connection, I'm getting audio. So if you're having trouble getting audio, you might need to follow the instructions to dial in with a phone and get audio if it's not coming through on the app or the web. Okay. Back to where we were. On the cluster overview slide here, I've got two layouts here. It's the same unit, but I need to make this distinction very important. On the left is your physical layout, your actual layout. You can see, it goes from your LAN switch, and you've got it split out into two separate pieces of hardware, and it goes into your WAN switch and then out to the internet. Those could be multiple switches with lag, whatever, for extra redundancy, however that is. But think about it, that, physically, you've got two units, two separate units, and they've each got addresses in every subnet. You can see I've got, there's a shared LAN address on the inside, a shared WAN address on the outside, and then they have their individual addresses in every link. So, physically, yes, they're two units, but you need to think about it on the right. That's the logical layout. These two units are separate, but they're working together as one logical firewall. So when you think about it on your network, it's one entity. This cluster is one thing. It's not always it's not two separate firewalls from the perspective of the rest of your network. So you have your WAN, your cluster, and then the LAN. Things on the LAN only talk to the cluster using the shared addresses, the CARP addresses, whatever. Things on the WAN only talk to the cluster using the shared address. So logically, things there's only one address that most things are going to care about. There are some exceptions to that I'll go into as we go. So you need to think about this in your head, because we have people every once in a while wonder, well, my secondary is just sitting there all the time. It's doing nothing. I should be doing something more with it. No, you don't want to. They should be as close to identical as possible, and it's the whole purpose of it is to sit there and be ready in case it has to take over. It's not wasted space. It's actually, just waiting to fulfill its purpose. So don't fall into the trap of treating them as two separate units the whole time. They're really just two sides of the same configuration. Okay, so as I was mentioning there, logically, they become one single unit from the perspective of the network. And how that is accomplished is through IP address redundancy, which uses CARP. So traffic to and from the cluster uses those VIP addresses. You have configuration synchronization, which is done by XMLRPC. So the two nodes will talk to, the primary node will sync over its configuration to the secondary to keep the configuration similar. And then we have state synchronization, or pfSync, which shares connection or state information between all of the nodes. So the primary shares its state information and changes over to the secondary. Secondary shares its state information and changes back to the primary. So the two together maintain that state table together. Keeping up with the theory here, for IP address redundancy by CARP, these CARP VIPs, and CARP, by the way, stands for Common Access Redundancy Protocol, they're shared between cluster nodes, and they work kind of like VRRP or HSRP, if you've seen those before in Cisco or HP or things like that. And because it works in a similar manner, it can conflict with those as well. What happens is every CARP VIP, on every interface is going to be transmitting out a heartbeat packet just about once per second. So any place that's got a CARP VIP, say you've got a CARP VIP on your WAN, you're going to have heartbeats on your WAN. You got CARP VIP on your LAN, you have heartbeats on your LAN. Your DMZ, you'll have heartbeats on the DMZ. So all of those happen on every interface where the VIPs are. That heartbeat traffic does not happen on the synchronized interface. They don't have, it doesn't share any failover information over that sync interface. So these heartbeats, they go out, like I said, approximately once per second, because you have your two components that determine the time for a CARP VIP are your base and your skew. Now the base is whole seconds, and skew is fractions of a second, or 1/256th of a second. So by default, you've got a base of 1, and your primary is going to have a skew of 0, and your secondary have a skew of about 100. So what that means is the primary is transmitting out these heartbeats a little bit faster than the secondary would. It's always going to be, it'd be about a second. And the secondary being at about halfway through that 256th of a second, it would actually, transmit out about a second and a half when it does transmit. By default, the secondary will only transmit if it stops seeing these heartbeats from the master. So how it determines who is master is wholly by these heartbeats. So if the secondary is always listening for these heartbeats, and if it stops receiving them from the primary, or if they start coming slower, say demotes itself, or they're just missing entirely, or something on the network is causing them to slow down, the secondary will say, oh, hey, I've got to take over. And then it will start transmitting heartbeats of its own, saying, okay, I'm out here, here's my timing, I'm going to take over this address, and then it will start handling that traffic. And then when the primary comes back, it'll start transmitting even faster than that. The secondary will say, oh, wait, that guy's faster, he's here now, I'll turn myself off. Then he gives up that status, and the master goes back to the primary. So this all comes together, and it gives you active and passive failover only. It doesn't do active-active where they're both handling traffic at the same time. Traffic to and from these CARP VIPs is only going to work properly from whichever of these two nodes has master status. Okay, so when I'm talking about traffic coming to the cluster, I'm talking about like routed inbound traffic on the WAN. Like if you've got a routed subnet from your ISP, they would route that into a CARP VIP. If you have VPNs like OpenVPN, IPsec, whatever, you'd want them to be listening or bound to the CARP VIP. If you've got port forwards, one-to-one NAT, whatever, they should be on CARP VIPs or something. Or I'll talk about a couple other ways to accommodate that. On the inside of your network, your clients should be using the CARP VIP for their gateway, and your clients should be using your CARP VIP for DNS if they're using the firewall for DNS. That way, everything is talking to the CARP VIP, so your clients don't know or care which one is up. They just know they can reach the CARP VIP. No, there are a couple of exceptions to that. You do not want to use the CARP VIP when you, a firewall administrator, are managing these devices. You only ever want to access them directly by their independent addresses. And that's the major exception, is just when you're managing these two, you manage them separately. Logically on the network, they work together to act as one unit, but you still manage them individually. And also, if you have a monitoring system, like Zabbix, Pandora, whatever, you want to monitor them individually rather than monitoring the cluster addresses. Now, you can monitor the cluster address in addition to the two units separately, but always, consider each unit separately, because if you monitor the CARP VIP only and your secondary dies, you wouldn't know that if you only ever monitored the CARP traffic. Because your monitoring system wouldn't ever see that was down until your primary went down and then you were dead in the water. So when you're monitoring these, you need to monitor both of them individually. Now, when I'm saying traffic leaving from the cluster, we're talking about outbound NAT and VPNs. So when you do outbound NAT, you need to make sure that you're translating this traffic to a CARP VIP on the way out. That's important for two different reasons. Number one, so that return traffic can come back to the CARP VIP and it'll go to whichever node happens to be master. Number two, because of your state synchronization is going to have a record of these NAT translations from the inside to the outside, and when it NATs to the CARP VIP, the state is valid on both units. So if that connection fails over to the other unit, it's still a valid connection, traffic will still flow. If you don't take that outbound NAT step, the traffic will exit out, traffic with NAT anyway, will exit out of the WAN address of the primary, for example, and if that fails over to the second unit, that address isn't on the secondary, so the state's not valid, so the traffic or connection will just die. So really important to make sure that you're using these on the inside, on the outside for any traffic coming to the firewall uses a CARP VIP, any traffic leaving the firewall, in a manner that's going to matter is going to want to use the CARP VIP as a source. So this failover, a little bit more about that. When an interface loses link, like say you unplug a WAN, and that WAN had a VIP on it, or a CARP VIP on it, this firewall is going to say, oh, hey, I lost link on that, and I need to demote myself. So it's going to add 240 to its queue, say, okay, well, I'm going to be slower now because I know I've got a problem. And the way we set that up on pfSense, we have a thing called preemptive failover. That means if one interface fails, all of the CARP VIPs are going to demote themselves, and so everything will shift over to the second unit. And that's really important because if your primary, for whatever reason, decided to only lose one interface and you didn't preempt, all of your primary, your WAN, say for example, your WAN would fail over to the secondary unit, but your LAN would still be on the primary, and you'd be down or dead. That wouldn't be a good situation. So preemptive failover is good because everything will fail over at once. But there are a couple of things you have to consider when it comes to that, though, which I'll get to in a moment. All right, next up is configuration synchronization with XMLRPC. Now, with configuration synchronization, we have uh, the sync interface we're going to talk about between the two units. And this is where where your configuration synchronization is going to happen. The primary is going to open a connection over to the secondary, and log in with the credentials you give it, and it'll push these settings over. And that happens pretty quickly in general. So it's always a good thing where it kind of keeps it all in line. So it's going to copy these settings over from the primary to the secondary, but there's only certain things that sync. It doesn't sync your interfaces, advanced settings, or your system general settings, and a lot of packages won't synchronize. Even some areas inside pfSense won't synchronize. Uh, so you need to be aware of what will and what won't sync. Because some things you don't want to, because the two units could have different hardware, they could have different requirements, you could have a little bit different configuration you need to make on these. So we do have some things that sync and some things that don't. And there might even be a case where you don't want something to sync that we do allow to sync, and you have some pretty fine-grained control over that that I'll cover as well. So for example, it will synchronize your rules, it will synchronize your NAT, aliases, VPNs, and a lot of other areas. And configuration synchronization, I will say it's not strictly required for high availability. It just makes your job of administrating it much easier. You could do all of these settings on both units by hand. You just have to make sure you're making the same edits to both units. It's just kind of a pain or a chore to do that, which is why the config sync will help you out greatly in that area. All right, next up, we have state synchronization. Now, state synchronization is pretty cool. It also communicates over the sync interface. So PF, or pfSense or PF and thus pfSense rather, keeps track of all your connection information in the state table. So somebody comes into the LAN and tries to make a connection that goes out. It'll have a state coming in the LAN, a state going out the WAN with its NAT translation, maybe a gateway choice, whatever, is all knowledge that PF keeps in the state table about that connection, because it has to allow that connection, like the return flow packets and everything back through. All of that matches the states. So it's pretty cool that where it can synchronize all of these things over, and it will synchronize the new states, anything expiring or deleting states, and updates. To the states that are exchanged between nodes. So if you make a TCP connection out, as it works through the three-way handshake, the state information will change to reflect the current state of the connection. So that's that kind of information is sent both ways. Also, the state table is interface bound state, has interface bound states. It means so if your WAN is IGB0, that state is going to have IGB0 in its state information, if it's on the WAN, obviously. And so when we do state synchronization, it's really important that your interfaces are identical on the two units. So if your WAN is IGB0 on your primary, it should be IGB0 on your secondary as well. Otherwise, the states won't line up. There's some ways you can work around that I'll talk about in a little bit. So because of the way the state table is synchronized between the two, if you've done everything properly when you do configuration sync and state sync, and CARP and everything, when the primary fails, your connections will just continue to flow through the secondary because it's already got a state. So you don't have to worry about the connection restarting. But it does, as I mentioned before, it requires the use of CARP VIPs with NAT, and you don't have any traffic going directly to each individual node, at least in the case of IPv4. Now, again, you don't need this to use HA. You can have failover without this. This just makes it seamless, or more likely to be seamless, less disruption, in other words. So if you don't have state synchronization, it's not the end of the world. You still, like if you had completely different hardware and you can't use state synchronization because none of the other workarounds would be viable for you, you can still fail over, but you might have some disruption. TCP connections would have to reestablish. UDP, normally can pick right back up. Things like that will, maybe VPNs obviously will have to reestablish either way. So you can work without state synchronization. It's just not as smooth. Another reason I mention that is at the moment, state synchronization or pfSync is not currently compatible with limiters. So if limiters are something you absolutely need at the moment, even on 2.4, you would have to do without state synchronization, or you'd have to do without limiters. You can't use them together at the moment. Okay, so before I get started any deeper, got a couple of assumptions we're gonna go over. I'm assuming you have two firewalls and they're both running pfSense software. They're already installed. Everything's going. You've got sort of a default configuration on them. Obviously, I'm not going to go that far back into the process. You could use 4 nodes. You can have 3 or 4 in a cluster, but we rarely see that, and it requires some manual adjustment. And we don't recommend running with that many. So it doesn't really give you a significant advantage over 2 nodes. But we do have people that have tried to run 3 or 4 in the past and with mixed success. So 2 is the sweet spot. Assuming these firewalls are at or near a default configuration, we're starting them pretty much from scratch here. You could convert an existing single installation over to HA. It can be done. It's just there's some other trickier things that happen in that process. I did cover that in the Hangout from last July. So if you're interested in that, after you finish up with this Hangout, go watch that one, and you'll see what the differences are having to work from an existing base. I'm assuming your firewalls have identical interfaces assigned in identical order. So if you go under interfaces and assignments, everything should be identical on both of them, the same order, the same interfaces and physical interfaces as well. And the 2 units have to have a non-conflicting configuration. What that mostly means is in the default configuration, they both want to be 192.168.1.1 on the LAN. You need to make sure they are not both the same before you plug them into the same network. So like on your secondary, change it to like .3 and turn off DHCP so there's not 2 DHCP servers on your LAN. You can go ahead and make the primary .2, which is what in the example what I'm going to use for the cluster anyway. Or you could leave it at .1 for the moment, as long as they have different addresses and that one of them has DHCP disabled until we get further into the process. That's where you need to start. And I may repeat that a few times because it's very important. We get people that try to plug 2 of them in at the same time and start a configuration, and it doesn't work very well because of the conflict. You don't know which one you're talking to, or they'll bounce back and forth. It's not good. So you may hear me repeat myself on a few points, and it's mostly just for emphasis because there are a couple of key things here that are very important that you get right. Okay, so you have a sync interface that you will want a sync interface. You may not have it yet. Normally with a cluster like this, you want at least 3 physical interfaces, one for the WAN, one for the LAN, one for synchronization. If you don't have that for whatever reason, I'll mention a couple of workarounds here in a moment. But assuming you do, again, make sure it's assigned and enabled on the same order. We call it the sync interface. We see a lot of people call it a CARP interface. It's not a CARP interface. It's an HA interface or a sync interface. That's fine, but really not even HA. There's no heartbeat traffic on that sync interface. There's no failover information happening there. It is purely for synchronization between the two, for configuration and state synchronization. So sync is the best kind of name for it. Now you can run through a significant amount of bandwidth for state table synchronization on here, especially if you got a lot of state churn or a lot of activity in your state table. If it's a really busy firewall with a lot of traffic, you're going to have a lot of state changes that need to be synchronized between the two, which is going to consume a fair amount of bandwidth. So that's why one of the many reasons that a dedicated interface is the best. Now, again, you could get by without the sync interface. If you don't have a physical interface available, you could use a VLAN, but because of the bandwidth requirements, we like to not use a VLAN for that if you can. Again, that's all varies by your environment. If you've got a pretty low traffic environment, it's not that critical that you have a separate one for that. A VLAN might be okay, but we really like to have that. If you can't use VLANs, you could use a secure internal interface for synchronization, but that can still be dangerous. I'm talking like something maybe like an isolated management network type thing, and not like your LAN. You don't want to have that traffic on a segment that is untrusted. where any untrusted clients could be. Because the pfSync or the state synchronization protocol has no authentication. So if you've got that on a segment where there are untrusted clients, anybody could insert state data into the state table and bypass firewall restrictions, which would not be good. So really make sure, if you're really in a bind and you only have two interfaces, you either isolate it on a VLAN if you can, or you may have to do without pfSync if you can't do it securely. And you can see on my two units I've got over here. I have a couple extra interfaces on here. I've got a DMZ and a WAN 2. I'm not really going to talk about those much, but mostly interested in WAN, LAN, and sync. And over here on my other node, again, the same interface order on both. You can see the same network ports and everything they're all assigned in the same order, and everything's pretty good. Everything's pretty good there. Okay, so talking more about the interface assignments, again, to reiterate, they have to be in the same number of interfaces, and they have to be assigned in identical order. And they have to be the same interfaces. And I'll mention this again because like say you've got two WANs, then both WANs have to be on both nodes. You can't have WAN 1 on your primary and WAN 2 on your secondary. HA and failover do not work that way. So they always have to be the same networks on the same switch segments, everything on all the interfaces. And these interfaces have to be in identical order. If anything is out of order on these interfaces, it's going to look like things synchronized to the wrong interface, or they might look like they disappear, or you can't find rules that were on the primary and they're nowhere on the secondary. Well, it might be because your interface assignments were not quite right, and maybe something that was on opt 3 on your primary, tried to go to opt 3 on your secondary, but maybe opt 3 doesn't exist on your secondary. So you can't find them in the GUI, but they're in the config. So you really need to make sure. And again, to reiterate, for state synchronization, you need to make sure that those interface types are the same, like I showed you. Like I've got VMX 0 on both of my WANs, both of my LANs are VMX 2, and so on. If you can't do that, like say you've got two different pieces of hardware, and one's got IGB and one's got EM NICs, you could, as a workaround, create lag interfaces, like using a failover protocol or something. So like your WAN would be lag 0 on both of them. Your WAN, and under that lag, you'd have IGB 0 on one and EM 0 on the other, for example. So you need to, but as far as the interface assignments are concerned and the states are concerned, it's lag 0. So you can work around it that way if you have to, but it's best to get matching hardware. And it doesn't even have to be completely identical as long as they use the same network drivers. So you could have two completely different boxes that both have, IGB 0 and IGB 1 and IGB 2. As long as, the interface names are the same, you'll be okay. Okay, so in terms of IP address requirements, this is where it gets a little tricky for some people because you do have to have static addressing, and you do have to have enough static addresses. So CARP itself requires a static IP address on your WAN for full functionality. You cannot use DHCP or PPPoE WANs for proper CARP. We've seen people try to make it work, and in some cases it can kind of function, but you can't get proper failover, especially with PPPoE, because they probably can't both be logged into that circuit at the same time. With DHCP, they might each pull an individual address, but they're going to have different WAN addresses, and they can't have CARP. So because, like I mentioned before, with state synchronization and whatnot, if the primary fails, your connections are going to all have to reestablish through the secondary. You're not going to have seamless failover. So CARP or static addresses are almost required, not 100% required, but definitely recommended. And okay, ideally you need 3 IP addresses per subnet per address family, except for your sync interface. So you need to have one address of each family type. So you got one IPv4, one IPv6 address, and a CARP VIP on each node. So you've got an address on your primary, an address on your secondary, and your shared VIP. So with IPv4, that means you need a /29 or a larger subnet. And for IPv6, a standard /64 is sufficient if your ISP is doing things properly. But if they're carving things out into small routing subnets, it couldn't be any smaller than a 126. There's no CARP on your sync interface, so you really just need the two addresses, one for your primary, one for your secondary. So for IPv4, you could get away with like a /30 there. Just for logistical reasons, it's easier conceptually to just use a /24 there, even though it's not necessary. But it's entirely up to you. You can use CARP with just a single IPv4 address. It is possible on current versions of pfSense, I think after 2.2 and later. So for your WANs, that means that only your active master is going to be able to communicate out that gateway or send traffic out. So only your primary would be able to do gateway monitoring. It would only be able to do updates, packages, anything like that. So because of that limitation, we don't recommend using that for your primary WAN or your default gateway WAN. Because your secondary is going to be out of commission because it can't, if you've got packages, you'd have to jump through hoops to get the packages installed over there. You have to fail over to your secondary manually, install your packages, install your updates, whatever, and that would be more disruption, potentially more downtime. But say you've got 3 or 4 WANs, then it's fine on your additional WANs, just not your primary WAN where where your firewalls are going to be reaching out for updates and things. You'd still have your gateway monitoring issues on the other WANs. So it may not be completely ideal, but it might be, if you're stuck with it and you really can't work around that, it may be better than nothing on those WANs. Now, I mean, you could, use that if you want. You just need to be aware of the caveats there. You don't really generally have these IP address restrictions on the LAN, so it's not a real concern there. But if you really wanted to, you could do, just a CARP VIP on an interface. But I wouldn't recommend even trying that. It's just not worth the hassle. So just again to repeat, if you've got multiple WANs, every WAN must be connected to every node. So if you've got 2 WANs, you got to have WAN 1 and WAN 2 on the primary and WAN 1 and WAN 2 on the secondary. And if you're interested in more about multi-WAN and CARP, go back and look at the July 2016 Hangout. I went over how to set that up. And as a reminder, for IPv6 clusters, you need to have separate routed subnets for each interface. So if you have a block of addresses, say like a /60 from your ISP coming in for IPv6, you'd have a 64 on your LAN, a different 64 on your DMZ, a different 64 for, say, a VPN, whatnot. Just to make sure you need to have enough subnets to go around for all your interfaces. If your ISP is only giving you 1/64, like your WAN address plus a routed 64, then you'd only have IPv6 on your LAN, for example. So just something to be aware of there. Now, before we start, one of the things you have to determine is what you can use for CARP. So every CARP VIP has an ID that it uses to identify its heartbeats on a segment. And there can be like 254 IDs, I think, in a segment, because the MAC address is determined by the ID. So and obviously it uses that to identify heartbeats and things from each other, so they know what they're listening for. So if you have 2 different clusters on the same network, you could have overlapping IDs, and it could cause a MAC conflict, and or they could get conflicting information about their failover protocol. So what you need to do is check first on your network, and I'll show you what this looks like here. You got diagnostics and packet capture. You just filter for CARP traffic, capture for a few seconds, and just look at the IDs you see on the segment, and just note those down and don't use them. So if I go to diagnostics and packet capture, I'm going to look at my WAN, and I'm going to filter on CARP. Start this for a couple of seconds. And stop. This is going to be a little weird because I've already got my CARP on here, so you'll see my own heartbeats. But you'll see here where it says VHID 11, VHID 77, 164. So 11, 77, 164, and then 11. So you can see this was going for about 4 seconds on that capture, because you usually got 4 heartbeats on there. So in that, right there, you'll see three IDs, 11, 77, 164. So if I were designing a new cluster to go in this segment, I would just avoid using IDs 11, 77, or 164. That's it. Just use anything else, 0 to 254, just not those three numbers, and it should be okay. So just need to make sure you're not going to send out conflicting heartbeat information. Now, the number one area you have to be concerned about this with is if your data center or your upstream, your WAN, ISP, whatever, if they are doing some kind of failover, you need to make sure you don't conflict with them. On the inside, you may have some infrastructure that uses something like this, especially like file servers or things that use it for IP failover on the inside. So, don't just assume you don't have this traffic. Always just check it out and just look and see if you do. If you do, it's not a big deal. Just find an ID, an open ID, and use it. If there's nothing there, then you can use whatever ID you want. You just can't use the same ID on the same layer 2. You could have the same ID on 3 different interfaces as long as there are separate layer 2s. Oh, and one other thing, this shows you pretty easily what it is, but if you have trouble interpreting this for some reason, you can also open this up in Wireshark and it will show you a little bit more information about the packets as well, including the IDs. All right, so a little bit of basic setup you need to do on both of these units. You want to give them each a unique name. You could have, firewall A or A and B, firewall pri and sec for primary and secondary, or 1 and 2. You could have, names, pairs of, whatever you want, as long as you know the relationship, and the relationship is somewhat obvious based on the names. But so a lot of people use like famous twins from mythology, or couples, or whatever, famous duos that you have in there. Just whatever names you want, just as long as it makes sense that you've got some relationship between these two. And that's just to help you in your management and in planning. So you want to make sure, again, to adjust these IP addresses so they don't conflict on your LANs, especially. Your primary is going to be like 192.168.1.2. Secondary is going to be 1.3. So you need to make sure that they don't conflict before you plug them in. Again, disables DHCP on the secondary because you don't want to create a conflicting network. Sorry. The firewall GUI must be running on the same protocol and port on both nodes. So the default of HTTPS on 443 is fine because they are both going to be on 443, both using HTTPS. So that's okay if you want to leave it that way, but if you change the port on one, you have to change the port on both. If for some reason you want to use HTTP, which we never recommend anymore, then you have to do HTTP on both, but I really don't do that. Just leave it on HTTPS and just change your port if you want to change anything at all. Your synchronization account, which is in most cases is going to be admin, that account cannot be disabled, so it's got to be active, and it has to have the same password on both nodes. Now on 2.4, you can use any user you want for synchronization. It just has to have the system HA node sync privilege. So as you'll see, I've got on mine here in my user manager, I've got the syncer user, and this user has system HA node sync. And a user that has this privilege will be able to use the XMLRPC system to push settings from one side to the other. So now the caveat is here, this account has to be created on the secondary. So you can do this one of two ways. You can do your initial synchronizations as admin with your admin password, and then once you've created this user, it'll synchronize over to the secondary automatically. And then once you've made sure the account is there, then you can switch your credentials over to using the sync account. Or you can manually create the sync account over on the secondary and let it go from there. That's entirely up to you, whichever way you prefer. Okay, and both nodes must have a static IP address on the WAN configured in the same WAN subnet. You got to have your gateway set up right, everything on there. So if you go like up here, you'll see I've got on my WANs static IPv4 and IPv6, and I've got my IPv4 address in my gateway, my IPv6 address in my gateway, and I've got the right subnet masks on here. I go over here to my secondary, look at its WAN, and same way, but with different addresses. See, I've got my Primary is .12 in both of these, or :12, and it's 13 in these. But they both have gateways set up on the interface for the WANs. And you also have to make sure you have a working proper DNS setup on here. The default configuration of using the DNS resolver, that'll be fine. You don't have to do anything to it. If you have the DNS resolver set in forwarding mode, which is not the default, or if you're using the DNS forwarder, then you'll have to go to System and General Setup and add in some DNS servers manually on each node. It could be Google Public DNS, your ISP DNS, your own internal DNS, whatever. But if you've got them in forwarding mode or using the DNS forwarder, you got to put some forwarders in there on both of them manually. Those settings won't sync, so you need to make sure it's set up on both. Talk for a moment about your switches. This is an extremely crucial component of CARP because these heartbeats are sent out with multicast for CARP. And because it uses multicast, the switch cannot block, filter, limit, or interfere with multicast at all. So we've seen in the past things like IGMP snooping or broadcast control, storm control, things like that will just freak out because of CARP. Sometimes because there's another problem on the switch or another problem with the switch configuration. Other times it's just because of buggy firmware, whatever. But these switches, you cannot interfere with the multicast traffic. You've got to let it flow between the nodes. So just about any time you see a CARP status problem, if it's showing dual master or dual backup or whatever, something is wrong in the layer 2. Either it's looping the traffic around and showing heartbeats are coming too fast, or it's blocking the traffic and nobody's receiving any heartbeats from anybody else. So anytime you see an incorrect CARP status, 90% of the time, if not 95, if not even a little higher, it's always the switch. So your switch or your virtual switch must at least allow multicast traffic to be sent and received by the firewalls without interference on these ports. It has to allow traffic to be sent and received by the firewall with multiple MAC addresses because traffic may go out using or come in using either the CARP MAC address or the physical MAC address of the NIC. So there could be 2 or more MAC addresses on that segment. You also have to allow the CARP VIP MAC to move between ports because it has to switch between the primaries port and the secondary port. And another thing, it has to be able to receive traffic for multiple MAC addresses as well. So for most regular switches, the default configuration is going to be okay for a lot of things. You don't have too much trouble, but virtual switches, especially vSwitches on ESX, you really need to make sure that you have either for the vSwitch or a port group just for the HA nodes, they have to have promiscuous mode enabled because they have to be able to receive traffic from multiple MAC addresses. They have to have forged transmits because it has to be able to send out traffic from multiple MAC addresses, and it has to allow MAC address changes, for the ports and whatnot. So those 3 security flags have to be allowed for ports where the firewalls are. You don't have to do it for the entire vSwitch. You can make a port group just for these that's a part of that vSwitch. So that's a little bit more secure and a little bit more efficient than doing it for the entire vSwitch, but you could do the entire vSwitch if you want. Okay, now onto the configuration of how you settle this stuff up. Again, a reminder, you need to make sure the secondary is disconnected from the network until you have a basic non-conflicting interface configuration on it. So again, make sure that your secondary's LAN IP address does not conflict with the primary, and also make sure you disable DHCP. I've said it, the 3rd time now, maybe the 4th I've said it, just because it's so important. You need to make sure you're not making a conflict and making it harder for yourself. First thing we're going to do is set up the sync interface, then we'll do pfSync, then XMLRPC, we'll add some CARP VIPs, talk about manual outbound NAT, do DHCP, then DHCP v6 and router advertisements, VPNs and other services, and then what you need to do to add more interfaces in the future. Okay, so for our sync interface, it's already been assigned. It was one of my assumptions. You can enable it and give it an address. Like I've got my sync interface here. I just made sure it's enabled. It's named sync. I've got IPv4 and IPv6 on this. IPv6 is optional. You don't have to do IPv6 on the sync network. You could use it for the GUI. I just did it because I had it on all of my other interfaces, and I thought, why not? pfSync I don't think can use IPv6 yet, but the config-sync could. I also, in terms of numbering, I use .2 and .3 on this interface again because my LANs are .2 and .3, so DMZ is .2 and .3, and just for consistency's sake, it was easier for the synchronization interface to also be .2 and .3, even though .1 won't be used on the sync interface. So again, on here, if you want, you do not want to set either of these block private or block bogons here on the sync interface, because odds are you're using private networks and that would just interfere with what you're doing, or you might be using some other kind of unassigned network that's not a private network, and you don't want to block that either. So this is going to be an isolated segment just between these two units, so that's not going to be a huge concern on here anyway. All right, so now you want to add some firewall rules for synchronization. So on the primary, we go to Firewall and Rules on the sync interface. And as you can see here, I've got a rule that will pass IPv4 and IPv6. You could just do IPv4 again if you're only using v4. From a source of my synchronization network, I have a destination set as this firewall just because it's an easy shorthand. You could do like from syncnet to syncnet or from syncnet to any or whatever. And I also have it set to just allow to admin ports, which includes the GUI port. So my admin ports alias, if you'll look here, it's got 80, 443, and 22, which is just an easy shorthand because I might use it other places. That would also allow me to SSH from the primary to the secondary or the secondary to the primary, either way across that sync interface. For emergency purposes. Say the secondary fell completely off the network, but I could still reach it over the sync interface. It's good to have for troubleshooting and diagnostics. I've also got a rule here to pass pfSync traffic from a source of syncnet to a destination of any. This does use multicast or directed multicast in some cases, or it could be unicast. So depending on your configuration, it's usually easier just to allow pfSync from a source of syncnet to any. Again, it's an isolated segment, so it's not a huge concern to get that 100% right. And in fact, some people just put an any rule on the syncnet. I tend not to recommend that, though I see a lot of people do it. It's entirely a matter of preference. And lastly, I have another rule down here for diagnostic purposes, just to pass ICMP echo requests, which are pings, from the syncnet to this firewall. Now, these firewall rules, since we do, at this point on the example configuration, I don't have the synchronization set up, so they wouldn't sync yet. So what you normally would do on the secondary, even though I've got all of my rules on the secondary right now because I do have the sync set up, normally you would just add a rule to pass any, or from syncnet to any. And I do it that way because it's a good reference to go back after you've got your config sync set up to go back and look, and it's obvious that the rules have been changed because now you've got all of your rules. See, they match up perfectly. So that's entirely up to you, however way you want to do that. You could create all of these by hand on the secondary. I just do an any rule, let the config sync clobber it, and then I know the sync is working. I do a destination of this firewall just as kind of a shorthand, but you could say sync address as well on there. I tend to allow a little bit more because you're able to get there however you need to, as long as you're routing across that sync interface. Logically, it's not going to make a huge difference. All right, next up is pfSync. Now this does get enabled on both nodes. So we go to System and High Availability Sync. Up here in the State Synchronization Settings part, you want to check Synchronize States, set your synchronized interface to your sync interface, and then set your peer address here to the IP address on the sync interface of your other node. So the IP address of my secondary in this case is 10.11.2.3. I come over here to my secondary, go to the same place, System High Avail Sync. I've got states enabled, synchronized interface sync, and my peer address is the address of my primary, 10.11.2.2. So again, if you don't want to do state synchronization, you don't have to enable this, or if you can't, If you leave the peer addresses blank, they'll try to use multicast to talk back and forth, which can work, but it's more reliable to put the peer addresses in. So just put in the opposing node address and you're good. You can save now, or you can do the next part, XMLRPC first, and then save after that. Now, XMLRPC, the config sync, that only gets enabled in the primary node. And you'll see here my secondary, it's blank, which is what you want. Now, coming over here to my primary in the configuration synchronization settings, the synchronized address is the peer address on the sync. So it's the secondary's address on the sync interface. I have my user filled in there. I've got my syncer user and I've got the password and confirm password, which again is just the stat password for that user on the secondary, which because my users are synced, they'll both work. And you'll see down here all of the different options we have to synchronize things. We can synchronize user manager and groups, authentication servers, certificates, certificate authorities, revocation lists, firewall rules, schedules and aliases, NAT, IPsec, OpenVPN, DHCP server settings. Note that v6 doesn't sync, and I'll tell you why in a bit. And when we do set up DHCP, we'll set up failover in DHCP, and I'll show you how that works. It automatically adjusts some of the settings so they work in tandem, and it does share leases and other information across the two. Your wake on LAN, you got static routes, load balancer, virtual IPs, traffic shaper and limiters, DNS forwarder and resolver, and captive portal. So any of these you can sync. You can use the toggle all to check everything if nothing is checked, or you can just leave it all checked. You can pick and choose what you want, but most of the time you're going to want all of these synchronizing. So and if you're not using a section, it really doesn't make sense just to uncheck it just because you don't use it. I may as well you don't know if you might change your mind in the future, and you might forget to come back here and fix this. So just make sure you get everything checked. Now, again, just to reiterate, that synchronization user, it can be on 2.4. It can be any user you want. It just has to have that system HA node sync privilege. On 2.3 and earlier, you have to use the admin user. So your admin password, has to match on both units as well. If you choose to synchronize your users, your admin password will have to be the same. It'll end up the same on both of them. Same with your sync user, whatever. So your usernames and passwords are going to end up the same on both units anyway. But if you don't want to use your admin user, you can get around that here. Just set up a second account for the syncing, or an additional account for the syncing, and once it's on both nodes, set that up there. Let's see, and your password and that's it. On the secondary, again, make sure you have nothing in this area on the secondary, nothing at all. And then you can save, and it'll immediately do a configuration synchronization as soon as you save this with those settings in place. Nope. Acrobat died on me. Let me pull my spreadsheet or my PDF back up. And find where I was. Okay, now we got to add the CARP VIPs. So we go to interfaces, firewall and virtual IPs, only on the primary node, because at this point we should have configuration synchronization set up. So you can rely on that to sync these settings over. And before we do this, you could at this point go to make sure it worked. You can check your logs. You can also go to firewall and rules, where we did the sync rules, and make sure you've got your synchronized rules over here. So that's just a way to check that out. So we got our CARP VIPs here under firewall and virtual IPs and other VIPs too. You want to add a CARP VIP for every interface except for sync, and then one of each type. So like I've got an IPv4, on my WAN, and I've got an IPv6 on my WAN. I've got IPv4 on my LAN, IPv6 on my LAN, and same with DMZ. Now the WAN 2 on this, I'm not really using. It was just here and I forgot to remove it, but it doesn't have IPv6 on that WAN 2, so it's only got the v4 address there. So what you do when you add these, you want to choose type as CARP. You got the right interface. You put in the address for the VIP, and then you pick the same subnet mask you have on your interface. And then this password here can be random. It just has to match in the password and confirm password box. Your VHID group here, again, just make sure you're using one of the IDs you noted was okay earlier. It could be any ID you want as long as it doesn't conflict with something else on that segment. And your base and skew, for most of the people, you're going to leave these set as default. So for example, on your primary, you're going to have a skew of 0 or 1, and the secondary, as it synchronizes that VIP over to the secondary, it's going to adjust that skew. So the secondary has a skew of like 100. So it's going to add 100 to that skew as it copies. So you just need to make sure you just leave those at the default. You know, unless you're trying to work around some sort of a network latency problem, you don't need to change the base or the skew. If a VIP is sensitive to latency, like say your secondary is in another building or another location, you can try and increase the base until you get it stable. But again, try not to do that if you can help it. All right. So you just repeat that process for all of your other VIPs. And then once you've got all of those in, you can come over here to status and CARP and check your VIP status. You'll see here it's got the CARP interface, which is it shows your WAN, like your WAN, and then the VHID. So it's WAN, you know, ID 11 on WAN, ID 12 on LAN, and so on. Has the actual address, and it shows your master backup status. I come over here and do status CARP on there. On the secondary unit, you'll see backup all the way down, which is what it should be. If for some reason you don't see it, like if the backup if you don't see backup here and the secondary is master as well, if you have dual master, again, you got to check out your switch for some. If that means if they're both master, that means that they are not seeing the advertisements from each other. So something is blocking those. It's almost always, I'd say 100% of the time, it's at layer 2. So you really can't misconfigure that. It's unless you've physically messed up the plugging things into different networks. There's not much to go wrong there, but even that's a switch problem or a physical connection problem. So check that status out and just repeat that as many times as you want. You can check the status after you add each VIP. You can add a group and then add the VIP and then check them after, whatever you want to do that way. If you have a bunch of addresses, like say you need to add 20 or 30 of these on a single interface, what you can do instead is you probably don't want to make individual CARP VIPs for those at that level. For a handful, sure, individual CARP VIPs are fine, but for a large number of them, you can set them as an IP alias type address and then choose for the interface, choose one of your VIPs. What that does is it kind of stacks that IP alias on top of that CARP VIP, and that will fail as a group. So say you've got a bunch of them, it saves you on heartbeats because you only have one heartbeat that you're worried about. And if that IP address goes down, then that whole group of addresses will fail over to the secondary. So that's really nice for making sure that you don't have too much heartbeat traffic, and also for making sure things fail as a whole and not just in pieces. And once again, to reiterate, or I'm not sure, I can't remember if I mentioned this or not, but if you've got a CARP VIP on an interface that is down or disabled, it's going to cause the firewall to demote itself because it thinks it has a problem. So if you've got a second WAN or a DMZ interface or something that is not in use yet and it's unplugged, do not put CARP on it, because that will just cause you grief. Either that or bring up or fix the interface, but don't purposefully configure CARP on an interface you know is going to be down. And by that token, if you've got an interface that you know is going to be down for a prolonged period of time, remove the CARP VIPs from it, because it's just going to cause you trouble. It's going to think there's a problem. It's going to be trying to fail back and forth to each other, and it's not going to work properly. And something else, as long as we're showing you status CARP here, you can look at the pfSync nodes down here at the bottom, and that gives you an idea of your state synchronization. Normally, these should be approximately the same. So if you refresh both of them, normally when state sync is working, they should be about the same. I'm not sure why they're different at the moment, but one or two lines you might see different, but see, they've got mostly the same. They've got three out of five the same. So as long as the good majority of them are synchronized, it's what you're after. You'll see one or two different just because they're they are separate nodes, but the bulk of the sync nodes should be the same. Okay, let's see. Next is your NAT that you got to worry about. So again, we need to make sure that any traffic leaving looks like it came from the cluster. So again, just on the primary, go to your NAT, because this is another section that will synchronize. Go over here to your outbound tab under firewall and NAT. If it's on automatic, you need to switch to either hybrid or manual mode. You can do either one. If you go to hybrid mode, you can make your own set of rules that will translate traffic out to the CARP VIP. If you go to manual mode and hit save, it will create a whole set of rules for you, and you can edit each of those and change the CARP VIP. I went for hybrid mode here because what I like to do personally is make an RFC 1918 alias just as a catch-all for all these private networks. And that way I can just make a couple of rules here. I did 2 rules for each WAN, one that does the IPsec pass-through for static port on IPsec for UDP 500, and another that just does regular randomizing that out for that. And either way, what you need to set on these rules is the translation address needs to be a CARP VIP. Your CARP VIP on the WAN, or it could be an IP alias on a CARP VIP on the WAN, as long as it's something that's tied to a CARP VIP on a WAN. Whatever you do, do not set a source of any on any of these NAT rules. So no source of any. Don't be tempted by that, because that will also capture a NAT traffic from your firewall itself, which will cause you grief. It will cause you problems with gateway monitoring, update checking, whatever. So your secondary is going to lose connectivity out if you do that, because it's got a NAT rule that's translated into a CARP VIP, and that CARP VIP traffic is going to come back to the primary, not the secondary. So even though it has direct connectivity out, it's getting messed with. So do not use a source of any for that kind of a setup. If you want to take the easy route, do what I did: make an RFC 1918 alias, or an alias with a source that's big enough to cover any of your private internal networks, but does not cover your WAN. So again, if you need to add more interfaces later, you'll probably need to come back and add more NAT rules, unless you did like I did with this alias. So also, if you have any port forwards or one-to-one NAT, for example, here, you will also want to make use of the VIPs. Like on a port forward, your destination would be the CARP VIP. And if you've got, one-to-one NAT here, your external address will be a CARP VIP or an IP alias on a CARP VIP. All right, moving on to DHCP. For IPv4 DHCP, it's just a wrong one. Services and DHCP server. Most of your settings here can be the same as you wouldn't have normally, but the 2 main things you got to do: your DNS server has to be, 3 main things actually. DNS server has to be a CARP VIP. If you're using the firewall for DNS, your clients have to talk to that CARP VIP for DNS. Otherwise, it would hand out the firewall's own address, which for the primary would be the primary, for the secondary would be the secondary. So, and if the primary goes down, your clients wouldn't have DNS. So don't do that. And don't put both nodes in here individually either, because that's going to cause you grief too. You'd have to wait for the first one to time out. Just use the CARP VIP. If you're going to use the firewall, use the CARP VIP. For the gateway, you got to hand them the CARP VIP. And for the failover peer address, you need to put in the IP address of your secondary in this segment. So that's got to be your, I'm editing my LAN DHCP settings. So this has to be the IP address of the secondary in the LAN subnet, not the sync address, not some other subnet. It's got to be the IP address of the secondary in this same LAN segment. And when this configuration gets synchronized over to the secondary, it will put the firewall's LAN address in there for the other side to get back. So that makes it super easy. It will synchronize your static mappings and stuff too, if you want to copy those in as well. So, so after you've made sure you've got your DNS server set to the CARP VIP, gateway set to the CARP VIP, you got your failover IP set, save and apply that. If we go over here to our DHCP status, under status and DHCP leases, you'll see I've got my failover group. You'll see a failover group for each local interface, and I've got a normal status on here, which is perfect. Come over here to my DHCP leases. I've got a normal status on here as well. And the lease database should be the same on both. And you'll see here too, the host name is synchronized now. Finally they fixed that in the ISC DHCP daemon where it synchronizes host names. And the secondary may show one, at least offline. That just means that you're not talking to the secondary. You're only talking to the primary. So that's normal. So so you'll see that. You'll see the normal status. Everything is happy. That's what you want. So boom, done with IPv4. You could DHCP. You could repeat that for any other local interface you've got. Now talk a bit about DHCP-v6. At the moment, there is no failover concept for DHCP-v6. There's no spec. There's no RFC. There's a draft in progress, but nobody's implemented it in the ISC DHCP daemon. Because of that, we do not synchronize DHCP-v6 or router advertisement settings because you have to set them up separately. That said, there's no concept of failover, but it does work just fine. You can go to services and DHCP server on the primary node, and there's a couple different things you can do. On the router advertisement tab, you can set it to unmanaged or Slack, so the clients will determine their own addresses. So using that method, you don't have to worry too much about it. The two nodes will get along okay. Clients will make their own addresses, so you don't have to worry about a lease database, and they'll use router advertisements to figure out what gateway to use. Alternately, you can do a managed or assisted with DHCP-v6, but you have to set them up independently. So each firewall has to use a separate pool of addresses. So the primary, like I show here, it uses like :1 :000 up to :1 FFFF. The secondary does :2 : and and so on and so forth. So they're handing out from different pools in the same subnet, and that just means that it's going to get its address and the DNS settings from DHCP. It's not going to matter. They're in the same segment. Gateway is always handled by router advertisements, not DHCP-v6. So you have a couple of choices there too. Each node is going to be advertising out that, hey, I'm a gateway and I'm a gateway. A couple of different ways you can handle that. You can do like I did here on this one. I've got on my LAN and router advertisements. I have it set to unmanaged just so they'll do Slack. It's not a big deal here for me on this one. I have a router priority of normal, and I have the interface set to my LAN VIP, my LAN CARP VIP for IPv6. And I have the secondary set up identically. So I go to DHCP-v6 on the LAN, go to router advertisements. Unmanaged, normal, set to the VIP. What that does is it only runs the router advertisement daemon on whichever node is master at the time. So when the primary is master, it'll be transmitting out saying, hey, I'm a gateway, hey, I'm a gateway. And if that goes down, then the secondary will come up and say, hey, now I'm the gateway, now I'm the gateway. And clients will pick that up pretty quick. I mean, you may lose a couple of pings, that's it. So it's not as good as going to a CARP VIP, for the gateway, but at the moment, at least, I don't think the daemon was capable of advertising the CARP VIP as the gateway itself. Even though you pick the interface, it just puts that on the interface. So if you do, the other option is to bind them both to the LAN. Like you'd set your secondary to a low priority. And over here you'd have LAN and a high priority on your primary. So primary would be high, secondary low. So then that way they're always both transmitting out that they're gateways, but they have their own priorities. And IPv6 on clients is smart enough to pick up the difference when they can't use one or use the other. And again, if you use the firewall for DNS, set the DNS to be your CARP VIP. If you are using the resolver unbound, you do just, after you've done all this, you do have to go to services DNS resolver and save at least once there, just so it can pick up on the new CARP addresses and everything. It'll pick up on the new VIPs and the other networks and things and just get a good restart. That isn't always required, but it's good just to make sure it gets refreshed because otherwise you may not have entries in the ACLs and everything else. Or it may not be bound to the CARP VIPs yet. For VPNs and other local services like OpenVPN or IPsec, you want to go into there and set your interface binding to be the CARP VIP. Now, in case of like OpenVPN clients, it will only run the client on whichever node is master, so they don't conflict. Support in packages varies. So, some will support CARP VIP, some will have XMLRPC, some will have CARP status detection, for example, like Quagga for routing. It has a place where you can pick a CARP VIP and it will monitor that status and fail over based on the that CARP VIP status. Another special case is the Acme package for Let's Encrypt. You want to install that only on the primary. You don't even install it on the secondary because you make a cert on the primary with all of your SAN entries. So you have a SAN entry for your primary, your secondary, and for the CARP VIPs all in one certificate, like I've got here. If I look at my thing here, you'll see I've got my keys and everything there for that, and that package is nowhere. I have it installed in the secondary, but it's not configured. So you don't have to worry about that too much. You do have the ability to set that up. So when you do that, depending on the update method you use, like I use the update method of the DNS update method, NS update, and it will go and update these certificates and everything, make all of them on the primary. So it's really just one certificate with 3 SANs. And then the configuration synchronization will automatically push that over to the secondary, and then it will automatically pick that up, so you don't have to worry about it too much. After it's over there, you just go into this GUI on the secondary and pick it for the GUI cert, and you'll be good. So everything's fine there. So when you go to add a new local, and that takes care of that. So you can do that. And so I don't know if you noticed, but both of these are actually using the Let's Encrypt, and they've got the same. Well, it makes it kind of tricky to view it here in the details, but if you look at your alternative names, I've got my secondary, my primary, and their shared host name, the host name for the CARP VIP. That way I could use that same certificate for anything, where that would be coming into the firewall as well, if I needed to. Okay, so that said, again, just a little reiterate too, if you're adding a new local interface, say you only had a LAN, you come along later, you want to add a DMZ. You have to assign the interface on both of them identically, enable it on both, use a different IP address in the same subnet, set up your CARP VIP in the new subnet on the primary only, add firewall rules on the primary only, add your manual outbound NAT, translating to the CARP VIP for the primary only. That may not be necessary if you use my alias trick. And then configure your DHCP and DHCPv6 depending on how you want to set that up and what you've got. So when you go to test this out, really you just need to have a client on the LAN trying to pass through surfing, browsing, watching a video on YouTube, whatever. And you can verify the XMLRPC sync like I showed you. You can also go to status and filter reload and force a config sync. You can go to CARP and status and CARP, and check and see your VIP status, if it's okay. If you go to status and CARP here, if for some reason you have an interface in a NIT, you'll see a button to reset the demotion counter. Don't be tempted to hit that. It's a temporary, very, very temporary fix, and it can actually end up messing up the status in the long run unless you really know what you're doing. We have the button there because there are a couple of good use cases for it, but really most of the time you don't want to hit that. You can verify the state synchronization by checking the pfSync nodes like I showed you. For testing failover, the easiest thing to do is to use this persistent CARP maintenance mode because it's the nicest way to do it. You could temporarily disable CARP. What that does is it actually rips all the CARP VIPs off the interfaces and deconfigures them. That does not last forever. That only lasts until you hit the button to enable it again or until you reboot. Persistent CARP maintenance mode is persistent across reboots. So it will actually carry over to the, if you need to reboot, you'll be fine. So if you do enter CARP maintenance mode here on the primary, you'll see now they're all showing backup. I go over here to the secondary, go to status and CARP. Now you're all master over here. Come back over here and leave maintenance mode. Sometimes it switches pretty quick, but the status doesn't always pick up. So I just got to reload the CARP page here. Now they're all master. Now you're all back up. So, I mean, you can do that, switch over while you're downloading something on a client just to check it out. Now, if you're downloading a file, streaming audio, video, whatever, that's probably not going to have that big of a, it may not even see a problem. It may completely continue uninterrupted. VoIP could be a little bit more sensitive. There might be a little hiccup in the call because it's not buffered. But you know, it'll be pretty good, pretty straightforward test. So if you're looking for troubleshooting, you know, just go back and make sure, you know, go back through the rest of this presentation and make sure you followed everything right. Check your CARP status. If a VIP shows a NIT, make sure it's got a link. You can also edit, save, and apply the VIP just to make sure it's reapplied on the interface, or remove the VIP from the interface if it's an interface that's going to be down. You can check for conflicting VHIDs like I showed you. Make sure all your subnet masks are right on all your CARP VIPs. And look at your switch and layer 2 issues again. Make sure they're using the correct switch layer 2 or the same VLANs, everything. So everything's got to match up for each node. Try to ping between the two nodes. Make sure they can see each other at layer 3. If you're using VLANs, make sure your switches are trunking the same VLANs on the same ports on both switches. And if it's multiple switches, that they're trunking together or stacked. You can also swap out a switch for another switch. Like if you've got a cheap little ISP modem or CPE that's got a few ports on the back of it, those switches are notoriously buggy, and you may have to put a real switch out there. You could, you know, check for things like IGMP snooping, broadcast multicast storm control. Like I mentioned earlier, check promiscuous mode, forge transmits, and MAC changes if you're on a hypervisor vSwitch type thing. So all that kind of stuff. Check your system logs, firewall logs, notices, because you know you could have traditional firewall problems that have nothing to do with failover. Things may not be working right there, but odds are, you know, it's going to go pretty smooth if you started from scratch. So what do you do when it comes time to upgrade these things? Well, first off, you need to review the change log and the blog post and the upgrade guide. Make sure it's the update. Make sure you know everything about it, any potential pitfalls that might come from it. And sometimes we have special cases or special handling for upgrading redundant firewalls or HA, which is that second link there. So you need to read those and make sure there's nothing specific that applies to you here. And before, you know, after you do that, before you do anything else, you have to take a backup. I cannot stress that enough. Again, take a backup and make sure it's good, because I cannot tell you how many times that we have encountered a customer that has an HA cluster and their primary blew up and they didn't have a backup of their primary anywhere. So always keep taking backups of both units all the time, especially before an upgrade though. You really need to make sure you've always got these. You know, if for some reason you do lose a unit and you don't have a backup, there are a lot of hoops you can jump through to convert one into like a secondary into a primary and then make a new secondary, or where you try to edit the configuration and turn it back into a primary. It can be done. It's kind of ugly. I mean, you can talk to us as support if you need something like that done, but really you need to make sure that you have these backups and you don't lose them in the first place. That's the best solution. If you're watching this, you've got a gold sub, so you've got access to the autoconfig backup package. You should have this on both nodes and you're using it. So there's no excuse there. Before you move any further to, if you're upgrading, say you made a cluster on 2.2, something like 2.2.3, 2.2.4, whatever, and you need to upgrade to a current version, make sure you disable the config sync, because there was a bug back then that could overwrite configuration. That got fixed in 2.2.5. It's not a big concern these days, but it's still worth mentioning. First off, you upgrade your secondary, you check, and then after you upgrade it, you check it out, look at the logs, status pages, service status, whatever, make sure everything's still running, looks okay. Then on the primary, you put the primary in maintenance mode, then you test the secondary again, make sure you still have connectivity, make sure your services are running, make sure everything's working. If something fails, you can just kick the primary out of maintenance mode and then fix it, and so you don't have any more downtime, and then try it all again. If your secondary checked out okay, leave your primary in maintenance mode and then reboot it, and then upgrade it. And after the reboot, it'll still be in maintenance mode. So check it over, look it over, make sure everything's good, the logs look good, services are okay, everything's looking okay, kosher, whatever. If it looks right, then exit maintenance mode on the primary, test it again. So then make sure everything is still working for your clients on your LAN. If everything's still working, everything's good. If you disabled XMLRPC earlier, then you can enable it again, then test your sync. So really what it boils down to is upgrade your secondary first, test out your secondary, upgrade your primary, then test it all again. All right, that's it. Went a little longer than I timed it out as, but I guess I went off on a couple little tangents there. But our Hangout topics in the past that are related, if you look at the July 2016 Hangout in the archive, it's got multi-WAN or converting an existing firewall to HA. This particular Hangout that I just finished will give you a good foundation. But if you need to move on a little bit from that, you can look at the other Hangout too. There's not that much difference in when I did that Hangout to now. It should still all be relevant. If you need some help getting IPv6 going in general, you can look at the July 2015 Hangout for the IPv6 basics. But that's it. If anybody's got any questions, I've got just a couple of minutes to take questions, and then we'll be done. Let's see. Are there any use cases where config sync is used for a non-HA setup, such as synchronizing aliases certs to users only? I will tell you there are people that do that, and we never recommend doing that. It's not designed for that, but we have, people have used it. We do have a central management platform coming that is actually going to be intended to do things like that, but we've had people try and like daisy chain 3 or 4 things together, copying aliases around. It's really kind of ugly. You could use like URL table aliases so they all pull from the same pool or something instead, but doing config sync for that, while it may function, it's definitely not recommended, not something we would support. In other words, it's really just meant for HA. It's not really an API or anything like that. All right. What are the use cases for that button you said don't click? Oh, you're talking about resetting the CARP demotion status? I think we may have turned off all the other things for it, but there used to be cases where an interface send error or a pfSync error would cause a demotion event. And so those were really temporary, but there was no way to recover from those. So if you got a demotion because of an interface error and you made sure the interfaces were okay, you could reset the demotion counter without having to reboot the box or clearing the interface stats, whatever. It was one of those situations where, unlike an interface event where the interface goes down, it adds 240 to the SKU, the interface comes back up, it subtracts 240 from the SKU. The other demotion factor cases had no recovery path, and so we had to have that button to reset the demotion status for those cases where you had to manually intervene. But I'm not sure any of those are left. I think we've turned the demotion factors off for all of those, but we've still left the button just because there might be a case we haven't thought of yet or may pop back up. All right. Anybody else? Any other questions? Let's see. On my WAN, I have a /28 with 10 virtual IPs as IP aliases. In order to run this, would I really need 30 IPs? No. Well, I mean, if you've got 10 virtual IP aliases, one of those could be a CARP VIP. The other 9 could be aliased onto that CARP VIP. You don't, if you just have a /28 on your WAN, you're just talking about just that one segment. You don't need to have, you just need 3 IP addresses out of that /28, one for each node plus your first CARP VIP. And then beyond that, it's just a matter of either doing additional CARP VIPs or stacking, IP aliases on top of that first CARP VIP. Either way, with 10 IPs, you really, it's up to you. It's kind of about at the breaking point where you might want to do the IP aliases thing. So, yeah, you don't have to do. I don't know where you would get 30 out of that, but no, you don't have to worry about that. You don't have to do that much. Just if it's all in one subnet, then you just have one IP each plus your VIPs. let's see, a while back I had NTP problems from the secondary, turned out needed to NAT back to the WAN CARP IP, something went up. Now that's, you probably had sort of what I was mentioning back there, like a source of any on your CARP, or sorry, a source of any on your outbound NAT rules, which would really mess up traffic from the secondary. And then what you probably did above that was essentially made an exception to that NAT, which is another way to work around that. But the best thing to do is just not use any as your source. Just use a proper source on your outbound NAT, and you won't have those problems to start with. All right, I think I got time for maybe one more question. Anybody else? Going once? Going twice? Oh, when is 2.4 coming out? Very soon. We don't have a good timeline for it. We're hoping like end of March, end of April, but we hit a couple of roadblocks with some more advanced bugs we were trying to squish, and we're trying to, once we got those cleared, we need to make another big push, but it's getting pretty close. It's actually really good shape right now, but there's still a couple of things we need to fix up before release. But we're blocked by a couple of issues we gotta get through, and unfortunately, they're issues that only one or two people can work on. It's not something that a lot of people can collaborate on. We just gotta wait for those to get cleared up, and then we'll get going. So. Let's see. Oh, one more. Anything to say about the Intel bug? Anything we've got's on the blog. That particular bug that you're probably talking about is not related to the firmware update, though I will say we've had a couple of posts on the forum and other things from our guys about it. Most of the SG units don't even use the bus that's got the problem, so it's pretty much a non-issue. So I wouldn't really be concerned about it. And for the other errata, update your core boot and you're fine. I wouldn't really worry about it. All right, well, I got to cut that short. We've been ran over a little bit too much. I got to get going. So thank you, everybody, for attending, and we'll see you back here next month.